Hi, welcome back. Hope you had a great break. I will be back soon, but for now, a video lesson today, and you'll have practice tomorrow on Delta Math. So before break, we talked about sequences. Now we're talking about summations and adding together these sequences that we discussed before break. So the do now, just to remember what a geometric sequence is, that means there's a common ratio. So for each, I took the second term, divided it by the first, the third term, divided it by the term before it, took each term and divided it by the term in front of it. In the first case, those quotients were all equal to negative 0.75. In choices 2, 3, and 4, the first two ratios were not even equivalent, so therefore there's no common ratio, and it was just choice 1. No card, I did not remember to check what number we're up to. Let me see. Algebra 2 flip book, 66. So no card 66. The summation, we use sigma notation. So here's an example of sigma notation. It has that Greek letter sigma. The lower limit, it tells you that n is going to start at 1 and go up to including 5. That's your upper limit. And we're going to plug it into this explicit formula. So the summation of a specified number of terms of a sequence, God bless, could also be represented in a compact form called summation notation or sigma notation. The Greek capital letter sigma is used to indicate a sum. So this is what it looks like if you write it out. Using this expression, plug in every number from 1 to 5. So 2 times 1, 2 times 2, 2 times 3, all the way to 2 times 5. And you add the answers to each of those together. So it could be a lengthy process. To write the terms of the series, replace n by the consecutive integers from 1 to 5 as shown. Or we could do it in the calculator. So we need to use the command. So if you go in the first input, I'm pressing the 3 dots to get to the commands menu, search for sum. And then you put the expression, in this case is 2n. So 2, and note you have to use the letter n. So that's different than usual. Comma, n, comma, then go back to the numbers to put the lower limit, comma, the upper limit, enter, and there's your answer. All right, so there's not much to write here. I'm actually going to erase all my scribbles before screenshotting this and putting it in my note card, which I'll do after the video. So for number 1, here they're using j as the variable instead of n, but when we put it in the calculator, if you put it in the calculator, I would have to use n. But let's just first do it without the calculator. I would put every number from 1 up to 4 and including 4. So 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, and 4 squared plus 1. So the j is getting replaced by every number 1 through and including 4. Simplify each of these. You get 2, 5, 10, and 17. Add these all, and I believe it looks like it would be 34. Or you could do it in the calculator, like we had just done. Commands, sum, in my letter, oh no, sorry, first I have to put, n squared plus 1, comma, then I put the letter n, comma, and then the lower bound was 1, comma, the upper bound was 4, and I get the same answer. Now for the next one, I'm actually not going to be able to do that because there's going to be a variable in the answer. So when I look at this expression, there's 2 variables. There's the I and then there's x. Since the lower bound number is given as I equals 2, the I is going to be what's replaced by 2. The x is going to stay. And then I'm going to plug in all the way through 4. So this is what that's going to look like. The I gets replaced by 2. My pen just died.